In this video, we're going to use triple integration with cylindrical coordinates to work out the volume of this solid here, So here you've got a sphere of radius 2, and we're going to slice this sphere at a height of 1. So our job now is to work out the volume of this solid. So in cylindrical form, it would be looking at the inner integral, it would be us moving in the z direction. So as you're moving in the z direction, you enter a z equals 1, an elevation of 1, and then you leave the surface. You enter z equals 1, and then you leave the surface. And then you enter z equals 1, and then you leave the surface. So you enter z equals 1, and then you leave this surface. Well, what is this surface? It would be z equals something. So if you want to know this surface, then rearrange this to make z the subject. So take away, so z would be z equals square root of 4 minus x squared minus y squared. You get the positive version and the negative version. You don't really care about the negative version. You're really interested in the positive version. So this would be root 4 minus x squared minus y squared. But that equals 4 minus r squared in cylindrical form. So it's really us integrating from z equals 1 to z equals root 4 minus r squared. And now looking at the next integral, looking at the next integral, so looking at the next integral, it would be r equals something. So once you've integrated with respect to z, this 3D solid will get projected down onto the XY plane. So now our domain is really this circle that has been projected down onto the XY plane. So we need to know the equation of this circle on the XY plane. Well, this circle here is the same as this circle up here because it has been projected down onto the XY plane. So we need to know the equation. We need to know the equation of this circle here. Well, to get the equation of this circle here, look at your surface, and at this elevation of 1, well, we can put 1 into the z here. So this will then become x squared plus y squared plus 1 equals 4. So really the equation of this circle is x squared plus y squared equals 3. So the radius of this circle, is of radius root 3. So in terms of r, you're integrating from a radius of 0 to a radius of root 3. So this circle here has a radius of root 3. So now we've taken care of the r. Now we've got to look at the angle, and you're integrating it from an angle of 0 all the way to an angle of 2 pi. So you're integrating from 0 to 2 pi. So our volume is given by this. So our volume is given by this. And now integrate it, looking at the inner integral, integrate this with respect to z. So that would be rz from 1 to this, And now put this into the z. That would then give us this, and then put 1 into the z. That would then give us r. So now integrate it. Before we can integrate it, let's visualize this thing as the bubble to the power of a half, because that is what square root is. And then now you can see that this is near enough the derivative of r squared, so you know it's going to be easy to integrate. So integrating this, we're looking for something in such a way that when you differentiate it, it gives you this. Well, I'm going to make this to be my initial guess, 4 minus r squared, and then one notch higher, that would be 3 over 2. So now when I differentiate this, it would be 3 over 2, the bubble stays the same, the power gets minus by 1, and then I've got to times the derivative of the bubble itself, which would be negative 2r. But then I don't, you see this r here? Well, we've done this many times. When you integrate this, it will then give you this thing here. So you can use substitution to integrate this. We've done this many times, so I'm expecting you to be able to integrate this. If you integrate this, it will give you this thing here. Integrate this, it will then give you this thing here, from 0 to root 3, from 0 to root 3. So that will then take us to to here. So now put root 3 into here. So when you square it, it will become the number 3. 4 take away 3 would be 1. And put root 3 into here. That will then give you this. Take away, and then put 0 into here. This will become 4. That would become this 4 here. And then blah blah from here will then take you to here. If you tidy up this whole thing here, it will give you this. And then tidy it up even further, that will then give you this thing here. Merge all those fractions together, that will give you this. Integrate it with respect to theta, that would then give you this. So your final volume is given by 5 pi over 3. Okay.